I will start in Portuguese and then
Okay.
we shift.
Okay.
So, muito bom dia para todas, todos e todes. É muito bom estar de novo aqui com o Ecoando Sustentabilidade para falar de um assunto muito delicado para todas, todos e todos nós, sobre elevação do nível do mar. E a gente conta hoje aqui com a doutora Kaitlin Naughten. So, thank you very much, Kaitlin, to be here with us. I know you should be right now very busy, so thank you very much.
Thank you for having me.
Yeah, thank you, man. And, well, let's... Now, agora eu vou traduzir, passar para o inglês, só para a doutora Kaitlin ter mais tranquilidade. Vou começar, então, falando sobre o currículo dela, e aí vou perguntar para ela um pouco daquilo que é o trabalho dela como modeladora do oceano. Lembrando para você que aqui na descrição está o link para você ir para a sala da tradução. Então, enquanto isso, por favor, você que tem alguma dificuldade com o inglês, checa no link, checa aqui no chat o link para você ir para uma sala para tradução simultânea. Tá bom? Enquanto isso, doutora Kaitlin Naughten is ocean modeler specializing in ice shelf, ocean and sea ice interactions around Antarctica. Her research primarily focuses on responses of Antarctica ice shelves to climate change. So it's quite important in this kind of moment that we are living, Kate, that, someone work with maths? How is that? We're in this very complex world, how to translate everything in numbers.
Yeah. Well, it is hard to accept this as someone looking at the beauty and complexity of the world, but it really all boils down to very simple physics and chemistry equations, which you can solve on a computer. And we have to make some approximations. Some approximations are related to the processes which we don't fully understand, and others are just related to the resolution of the model. That there's all ways of processes happening on a smaller scale than the smallest grid cell in your model. But climate models and ocean models really can represent quite accurately the behavior of this system, including ocean currents, changes in temperature, melting of ice, and we've been working on these models since about the 1970s. So there's been a lot of time and a lot of research devoted to making them as accurate as we can.
So, wow, the things people want to know about your paper. Unavoidable future about ice melting in West Antarctica. I will share the paper with you here. And can you tell us a little bit more about how it was to build this paper and to be success to publish it with this title? This is a very strong title.
Yes. So what's special about this paper is that we are looking at different scenarios of how West Antarctica could change in the future. We actually don't have a lot of future projections of how ice shelf melting in particular could change over the next century, of how ocean warming could change. We weren't even sure if the ocean would warm in the future, or if it might stay the same, or if it might even cool, because people just really hadn't done the science yet, because this is a difficult region to model with a lot of small-scale processes. So what we did, which no one else had done before, is we didn't just look at the best-case scenario of sorry, we didn't just look at the worst case scenario for fossil fuel emissions, which is what I have done previously. We also looked at the best case scenario where we meet the goals of the Paris Agreement, where we limit warming to 1.5 or 2 degrees Celsius worldwide. And we found that even in those cases, ocean warming didn't just continue, it sped up by about a factor of 3. So we also found that there's very little difference in between scenarios. And so that's what led us to use the word unavoidable, because no matter how much we reduce our greenhouse gas emissions, our modeling suggests that at this point, substantial increases in ocean temperature and ice shelf melting are committed, are already locked in. And so this is expected to have impacts for the grounded ice sheet and for sea level rise.
Okay, and well, here in this graph, everybody can follow, as Kaitlin said, we have here the Paris Agreement with 1.5 degrees of warming, and what we can see is the losses of ice is something around 100%. Is it right, Kaitlin? My interpretation.
Yeah.
Okay.
So this is an increase of 100% out of 200%. So that's a doubling to a tripling of the original melt rates. Yes.
Well, and what is the consequence of this melt? In other words, if we are talking about to lose all this ice cover, what that can change?
Yes.
Sea level rise, for example.
Yes. So the process that we're looking at here is called ice shelf basal melting. So that's the way that the ocean melts the floating ice shelves, which are the floating edges of the ice sheet. The ocean melts them from below. And this is currently the main process causing loss of ice in West Antarctica, which is Antarctica's largest contribution to sea level rise. And it's the process causing sea level rise on which we have the most uncertainty in the future. So it's important to know how it could change in the future. Generally, if this basal melting increases, which which our studies suggest that it will, the ice sheet, the glaciers which feed these ice shelves will tend to speed up, and that causes sea level rise. We already see this in observations. We see the ice shelves are thinning, the glaciers are speeding up, and the volume of West Antarctica as a whole is decreasing as it loses ice to the ocean. So we expect this sea level rise contribution to continue and to accelerate.
Yeah, and I have been in subantarctic region a couple weeks ago, and in the Arctic also 2 months ago, and man, after this summer in the North Hemisphere and with this weak winter in the South Hemisphere, well, we don't have a lot of ice around, and the melting process we can see with our eyes. I think this was a terrible year for sea ice, huh?
Yeah, so sea ice is a bit of a different process. Sea ice isn't directly connected to the ice sheet. Sea ice is just frozen sea water. So it's important to realize how these are separate processes. Sea ice responds much more quickly to year variations in the climate, whereas the ice sheet is a much slower and more gradual response, but also has a lot more inertia. But you are correct that we're seeing very dramatic changes in all different parts of the climate system in both the Antarctic and the Arctic, including sea ice.
So maybe the ocean warming is even more important in this case than atmospheric warming, or both are
Absolutely.
important?
Yeah. So for West Antarctica, ocean warming is actually the most important process because it's currently changes in the ocean, which we think are driving changes in the ice sheet. In this region of the world, the atmosphere is just so cold it can't cause any substantial surface melting. So really the only way to change the balance of melting and freezing is either to change snowfall or to melt the ice from below using the ocean. The ocean here is much warmer than the atmosphere, so it's a lot easier to melt the ice. It also has water has a much higher heat capacity than air, so water is very efficient at melting ice. You can see this if you have an ice cube in your drink, it will melt a lot faster than if you have an ice cube just sitting on the kitchen counter.
Yeah, well, we did a video explaining a bit your paper for broadcast, and well, a lot of negationists starting to say, oh, but it's ice on the sea, nothing will change. What we should say for this kind of people, just because, okay, we have a lot of ice shelves on sea, but they are a barrier to the ice that are on land, right?
Exactly. So ice shelves are already floating. So melting an ice shelf directly doesn't cause sea level rise, but indirectly it does, because the ice shelves cause what we call buttressing of the rest of the ice sheet, which is resting on the land. And so if you take away an ice shelf, or if you thin an ice shelf, in almost all cases, that grounded ice sheet will speed up. Exactly. And we already see this happening in observations. And that process does cause sea level rise.
So, Kate, where is the message for people and government, stakeholders, policymakers, what we should do? Just because, wow, this is an unavoidable future. We are talking about more than 5 meters of sea level rise just regarding the West Antarctic ice amount, right?
So that's the entire West Antarctic ice sheet melted. And we don't think the entire ice sheet would melt, even if you melted all of the bits resting below sea level, which the ocean again directly access. That's about 3 meters. So we're probably looking at the thing around 2 to 3 meters, but the time scale is uncertain. And there's also lots of other contribution to sea level rise, like East Antarctica, Greenland, mountain glaciers, the thermal expansion of seawater. But what this study tells us is that some amount of sea level rise is already committed on some time scale. The idea that we can just stop melting of West Antarctica in its tracks is not realistic. This process will continue. And so I think the message to stakeholders and policy makers is that we need to prepare for sea level rise, because we only expect it to continue to rise in the future. And the more that we can prepare for coastal communities to be flooded, the more we can do to protect human lives and communities, the better. It's better to plan ahead. If you have to relocate people, it's better to plan ahead. If you have a refugee crisis, than to wait until it happens.
Yeah, exactly. And another worry that I think we should have is these tipping points are related with other ones. And with all this amount of melt, we can have change in our currents. These big turnovers that we have in Atlantic should change, and this will change other things. For example, the vegetation or the forests we have in Amazon. So everything is quite interconnected. So the amount of methane we have in this ice, and all this methane are being released all the time. So this claim that you are presenting in your paper, I think, is an important message to COP28. Right?
Yes, there hasn't been a great deal of study on how different tipping points are connected, but you raised some interesting ideas, and yeah, definitely some areas of active study, especially interconnection with the North Atlantic overturning. It is something that we need to look at further, but you're absolutely correct that you can't expect such a large injection of fresh water into the ocean to not have an effect on the rest of the climate system. It will do something. The question is what it will do.
So just to share with our audiences, we have this paper, very important one, with this group led by James Hansen. Man, please read it, and please connect with your policymaker or someone that is working with the government right now in your city, on your state, or everywhere. Just because, if we connect the dots, this paper with what is stated in this State of Cryosphere, recently published, and with the paper of Kaitlin Group, then we have a very, very strong message regarding this moment that we are living right now. So just your last message to our audience, Kaitlin, and thank you very much again to be here with us. Guys, I was saying to Kaitlin, man, I think the science have a lot to help. And we ask for the policymakers, politicians, etc., to listen to science. At least now we still have some time to reduce a lot the damages of this terrible crisis that we are getting in. Please, Kaitlin, so thank you very much again, and your last message.
Thank you for having me. I agree. Even if West Antarctica cannot be saved, we can still save East Antarctica. It contains about 10 times as much ice as West Antarctica. So all indications are it's generally stable and should remain that way. So although some impacts of climate change are now unavoidable, we can always stop it from getting even worse. There's a lot of ice in the world, and there's a lot of it still to lose, which means that there's a lot of it that we can still protect.
So I'm so sorry, Gabrielle. Do you have any questions to Kate? Please do it. It's time to do.
Okay. Hello, Kate. Thank you. You know how much time do we have? Like, it's a century, it's a millennial, or it's decades?
Yes, so our study was looking specifically at ocean warming and ice shelf melting over the next 100 years, but the ice sheet response to that will be much longer than 100 years. It would take centuries to get the bulk of the sea level rise in response, and it would take actually millennia for the ice sheet to fully equilibrate. So the actual sea level rise we will see from West Antarctica before 2100 will probably be quite small, centimeters to maybe tens of centimeters. but until 2200, 2300, 2500, it could be several meters. So the time scale which we're actually looking at these sea level rise impacts on, it isn't the people who are alive today who will be directly affected. It's the generations to come.
Thank you.
So I think our audience is well, they don't have questions. Well, they are processing all that. That's quite hard to be processed. It's very hard. Well, man, when I read your paper, it was something, wow, unavoidable. And this is a huge response to our generation, just because, well, in 1 or 2 centuries, everything melting, Greenland, Antarctica, etc. We are talking about 10 meters in two centuries.
It's very uncertain as to how much and how long it'll take. And that's what my community and the scientific community is working hard to reduce these uncertainties. It could be anything from less than a meter to tens of meters over the next few centuries, and we don't have a good handle on that.
Okay. So again, if you have no more questions from our audience and from here, I need to say thank you in name of our university, in name of our people. Thank you, Kate, and congrats to your wonderful work. Work perfect, just because it started with a necessary title in this necessary moment. So thank you very much. Thank you.
Thank you so much for having me.
Thank
Lovely
you.
to meet you both.
Okay, bye-bye, Kate.
Bye-bye.
Okay, bye.